Before I give this presentation, I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to the elders, both past and present. Hello, and welcome to the future. Greenhouse gases are decreasing and the oceans are staying at a healthy temperature. Let me show you how this can be achieved. Global climate change, an ongoing issue that is going to keep arising. As we all know, one of the main causes is through the accumulation of anthropogenic greenhouse gases. These greenhouse gases are entering the atmosphere at around 400 parts per million each year. Where is this carbon going? Well, the oceans are acting like a giant CO2 sponge with over a third of anthropogenic carbon being absorbed into the sea. This important process, known as blue carbon, cycled through food chains and metabolic processes in seas and oceans, where it becomes bound or sequestered in natural systems. With this in mind, it has been found that over 90% of this excess heat is being absorbed by the oceans, yet it is making them highly acidic and raising the temperatures, becoming harmful to shellfish and all other marine biodiversity. Therefore, there needs to be a solution to permanently sequestering carbon without harming the marine ecosystems. Yes, it is true. Trees do store carbon when they photosynthesize and grow, using carbon as biomass to form new leaves and branches. Although this storage is highly vulnerable since deforestation releases this carbon back into the atmosphere, undoing the benefits. We are also most notably running out of available space of habitat on land. So when we're thinking about carbon sequestration, we need a permanent solution. Well, you're in luck, because I have a solution. Coastal ecosystems can sequester away surprisingly large amounts of carbon. They can sequester up to 20 times more carbon per acre than land forests. Marine plants that contribute to this carbon sequestration, such as macroalgae, live in rich soil. Because of low oxygen concentrations underwater, the plant material can stay buried for decades or longer before breaking down and releasing carbon dioxide back into the atmosphere. Although shallow nearshore waters are the natural habitat of most macroalgae, their range can be easily extended to the open sea through the use of seaweed aquaculture. So, what makes macroalgae so special? Well, macroalgae refers to a set of exceptionally diverse multicellular, non-vascular marine plants, also referred to as seaweed. Macroalgae broadly describes a number of green, red, and brown species. Macroalgae, such as kelp, usually grow near the shore in rocky and eroding conditions where plant materials cannot get buried. Instead, bits of macroalgae get exported to the deep sea where the carbon can be sequestered. Macroalgae have gas-filled bladders that help them float towards the surface where they receive more sunlight for photosynthesis. These gas-filled bladders allow bits of macroalgae to float for long distances and be carried far away from where their macroalgae is grown. Because they contain unpalatable compounds, macroalgae remain mostly uneaten as they travel across the ocean. Eventually, the air bladders burst and the macroalgae sink down towards the deep sea floor, where the carbon is thought to be sequestered away from the atmosphere for centuries. The sequestration of carbon is extremely important to emitting greenhouse gases, for the leading international body on climate change says we need to actively remove or sequester away carbon dioxide from the atmosphere to achieve negative carbon emissions and prevent climate catastrophe. By 2050, we should plan to have net zero emissions, meaning that all carbon emissions need to be balanced by carbon removal. This can be achieved through large-scale seaweed aquaculture. This is an important approach to counteract the current greenhouse effect and global climate change, which will have a significant impact on global carbon cycle. Seaweed can reduce the partial pressure of CO2 in surface seawater via photosynthesis, which favours diffusion of atmospheric CO2 into seawater, to then be buried in sediment. Through the commercial use of seaweed, this could also reduce carbon emissions, for they can replace food crops or petrochemicals that otherwise lead to additional carbon export to the atmosphere. Scientists Froelich, Afflerbach, Fraser, and Halpin stated in 2019 that new sectors are arising that may have substantial potential to help bolster our ability to counter emissions, one of the most promising being aquaculture. Seaweed aquaculture demonstrates the fastest growth of 8% per year, with kelp growing up to 2 feet per day, compared to the growth of a eucalyptus tree, which is 6 feet per year. This has been proven, for a paper published in 2016 in Nature Geosciences compiled data from previous studies in order to provide an estimate of how much atmospheric carbon is being removed by macroalgae. Their rough estimation suggests that around 200 million tons of carbon dioxide are being sequestered by macroalgae every year, which is equivalent to the annual emissions of the state of New York. A Korean project developed new baseline and monitoring methodologies for mitigation and adaptation using innovative research approaches. The coastal CO2 removal belt has been established, comprising both natural and man-made plant communities in the coastal region of southern Korea. This scheme promotes the removal of CO2 via marine forests. Using perennial brown alga, Eclonia, CCRB farm can draw down 10 tons of CO2 per hectare per year. Although carbon sequestration is necessary to slow climate change, carbon sequestration alone cannot prevent climate catastrophe unless we reduce our use of fossil fuels. Studies like this, however, highlight the importance of protecting valuable marine ecosystems such as kelp forests from environmental damage. As we decrease our use of fossil fuels, carbon sinks such as kelp forests will play a key role in getting us to net zero emissions. The potential for seagrass meadows to store carbon can be enhanced through various management approaches, including marine area protection, marine spatial planning, area-based fisheries management techniques, regulating coastal development, and ecosystem restoration. Seaweed aquaculture could be the solution we are looking for in preventing further damage to our planet. It will not only offset carbon emissions, but it will create jobs, supply food sources, and can be used as biofuels. The future is in your hands, Australia. Think of generations to come.